In this clip we will define the matrix-matrix product. Well, recall that we have defined the matrix vector product. Yeah, so how was this constructed? Well, suppose we have a matrix here, 1, 2, 3, 4, 5, 6, and we multiply it by a vector 2, 1. Then we make new components by forming a row column. In a product, we get 1 times 2 plus 2 times 1. And in the second coordinate we get 3 times 2 plus 4 times 1. And 5 times 2 plus 6 times 1 as the last coordinate. So the dimension of the matrix here are 3 times 2 and the vector is 2 times 1. It gives us a 3 times 1 vector. Well, a matrix-matrix product is actually not so much different. So suppose we take the same matrix 1, 2, 3, 4, 5, 6, and now we have two vectors, two column vectors, 2, 1 and 3, 4. So actually we have a matrix, a 3 times 2 matrix and a 2 by 2 other matrix. The inner dimensions agree. Then we just split up the second matrix following this blue line and we calculate 2 times a matrix vector product. So first we calculate the matrix vector product where the vector consists of 2, 1. And secondly, we form the matrix vector product with 3, 4. So if you follow the calculations here above, then we get 4, 10, 16, and the matrix vector product with 3, 4 gives us 11, 25, 39. And actually the results are now concatenated, so we get a 3 times 2 matrix. So if we look here, we get the outer dimensions, 3 times 2 and 2 by 2. Forget about the inner dimensions of the matrix and the vectors, and we get the result is a 3 times 2 matrix. So how does it look more formally? So here we provide a matrix-matrix product definition. So given a matrix A and a matrix B, where A is supposed to have dimensions n times m, and B is an m times p matrix, so the inner dimensions agree. Yeah, there should be the same number. Then we may define the product A times B, and it's going to be an n times p matrix, so forget about leave out this m here, and we get n times p matrix. So how is this defined? So suppose we have a matrix A and a matrix B. Now this is a schematic view. So suppose we have the ith row, that we can write it as AI1, AI2 until AIM. Yeah, A has m columns, B has m rows. And now suppose in B we take the jth column. So the jth column has elements B1j, B2j, etc. until BMJ. So this row I and the corresponding column J gives us the Cij, the ijth element in the matrix AB. Yeah, so again, this is row I and column J. And the intersection is the element Cij. And Cij is no more than the transpose of the vector, the row vector in A, dot product the column J in B. So we get as element Cij is AI1 times B1j plus AI2 B2j, etc. until AIM BMJ. So this sum can be written differently if we choose as an index I or an index K, then we have a sum of products of AIK BKJ. So AB is the matrix consisting of elements at Cij equaling this sum over here. Now we look at some examples of matrix multiplications, matrix products. So suppose we have a matrix 1, 2, 3, 4, 5, 6, 7, 8. So this is a 2 by 4 matrix. And we try to multiply it with the matrix 2, 0, 0, 2. Well, is this going to work? Well, we have a 2 times 4 matrix and a 2 times 2 matrix. And we immediately see that the inner dimensions do not agree. So this, we try to multiply these matrices, but it's simply not defined. Another example, we take the same matrix on the left, same 2 by 4 matrix 1, 2, 3, 4, 5, 6, 7, 8. And we multiply it by 1, 0, 1, 2. The first column, the second column 2, 0, 3, 2. And the last column 2, 1, 2, 3. So now we have a 2 by 4 matrix. And here we have a 4 times 3 matrix. So 2 by 4, 4 by 3. So the inner dimensions agree. And what we get is the 2 times 3 matrix. First we multiply on the left upper side. We get 1 times 1 plus 2 times 0 plus 3 times 1 plus 4 times 2, which equals 1 plus 0 plus 3 plus 8. The second element is no more than 1 times 2 plus 2 times 0, 3 times 3 plus 4 times 2, which equals 2 plus 9 plus 8. And the first row is completed by multiplying 1, 2, 3, 4 with 2, 1, 2, 3, which gives 1 times 2 plus 2 times 1 plus 3 times 2 plus 4 times 3, which equals 2 plus 2 plus 6 plus 12. Now we consider the second row. The second row we get by forming all products with the row 5, 6, 7, 8. So first we have the first element in the new row is 5 times 1 plus 6 times 0 plus 7 times 1 plus 8 times 2, which equals this number. The middle one is 5 times 2 plus 6 times 0 plus 7 times 3 plus 8 times 2, etc. So we get a matrix 2 by 3 matrix. And why is that? We could have concluded this before we started up the calculations, because we know that we can calculate the dimensions of the new matrix by just leaving out the inner dimensions. So we get a 2 times a 3 matrix over here, and it's the matrix over here.